Today, there is an urgent need of smart and sensible construction sites, which could benefit a lot from computer vision and automation technology. However, there is a lack of practical methods in application. So, for solving this lack, we put forward the corresponding innovation, which includes three parts: walking state monitoring, traffic safety alarm, and automatic progress monitoring.
This is achievement of our research. The function 1 is working status recognition of single worker based on DTW algorithm. This part will show you three motions, including shoveling, plastering, and shouldering. Firstly, shoveling. As we can see, the left image is real-time ragged UI, and the right is recognition UI. The worker is Ethan. Now he starts to shovel. When working, his hands show green. The weatherwork shows true. And the value of duration is accumulated. Meanwhile, the system recognizes he is shoveling. When Ethan stops shoveling, his hands become red. The weatherwork shows false and the duration stops accumulating. Secondly, plastering. We can identify whether Jackie is plastering or not and record his working time. Thirdly, shouldering. Similarly, the system recognizes whether Ethan is shouldering something. Function 2 is working status recognition of multi-workers based on gesture data. Ethan and Kyle are arranged to shovel. Their working information is showed in the same recognition UI frame. When Ethan is at work, in this column, shovel start shows true, and the duration is accumulated. When Kyle is at rest, shovel start shows full, and the value of duration stops accumulating. When the duration accumulation has stopped longer than 15 minutes, the system will issue.
Moving objects in the video will be detected with the green rectangle frame, which realizes the target motion detection. The centroid of the moving object is indicated by the blue point, and the trajectory of the moving object is drawn, which can realize the tracking of the moving object. Our system can identify the moving object and classify it as car, truck, or pedestrian. Also, the system can measure the speed of the vehicle passing the test line and mark it on the image. According to the coordinates of the moving object in the video image and the speed of the system can estimate the position of the target in the next moment, so as to realize the path prediction. When the moving vehicle and the pedestrian's visual angle constitute the visual blind area, the system will carry on an early warning. Finally, our system will record the vehicle information in the database, which provide data for information management.
This innovation accurately delineates the contours of the target components through integrating the voting algorithm, classifier, and each detection algorithm. Then, according to the camera calibration principle, the image pixel coordinates are converted into the real-world coordinates, which are corrected with the help of the geometric information in the as-built big model. Finally, the actual engineering quantity is calculated.